Hey everybody, Lars here. Here in the friendly confines of the computer science department at Rutgers University, gonna shoot the final review video for Unit 5. And in this one, we're gonna cover a whole bunch of different things, but none of them are really big enough so that it could be a topic on its own. Maybe it could be, but it'd have to be quick. So what I usually do is I shoot this last third video and I cover a whole bunch of different things. And you're gonna see at the end, when we finally get our finished product, it's going to look like a lot of stuff to you, but because you watched video 1, watched video 2, and you were along for the ride as we built it, you realize it's not that, it's not that big a thing. Once you learn the right way to design computer programs, things like what we're going to do today, they're really not that difficult. So let's go over some stuff. I already have the code that we used when we stopped our last video, video 2. No, let me just move that, put that there. As you can see, we ran a couple of different cat objects. I am going to leave that there, but what we're going to do real quick, watch how quick and easy this is. I'm going to take cat, I'm going to copy it. I'm going to come down here, I'm going to paste it, and I'm just going to call it dog. And then we're going to wait color, so colors, speak self. For meow, I will say woof. Could say woof, could say bark. I'll leave it at woof. And just that fast, we now have a dog class. And I am going to create a dog. I'm going to call him Fido. Fido is going to weigh 35 pounds. I will explain something in a minute. And Fido will be brown. An old brown dog. Let me capitalize that. Okay? So let's do that. Then let's get a second dog. And we will call this second dog Rex. And Rex will be a chunky monkey. We'll make him 55 pounds, and we will make Rex. Why am I doing double for Rex and not the other thing? We'll make him red. We'll make him an Irish setter. And as I usually say, I don't know if setters go that big, but what the who? One thing that I realized I forgot to do in the last video is explain to you what a 50-pound cat is. When you see a 50-pound cat, is it the cat's fault? No, it's the owner's fault because the stupid owner won't stop feeding the poor cat, and the cat eats everything that's put in front of it and it gets big and fat. So a colleague of mine here at Rutgers says that a lot of employees at Rutgers University, faculty and staff, are 50-pound cats because they're completely out of whack, but it's not their fault, it's their boss's fault because their boss lets them get away with murder. So you do that for about 5 years and then all of a sudden just the employee's gone rogue. they make themselves useless. So we call them 50-pound cats. All right? I digress, as usual. So that's why I always make Felix 50 pounds, and it makes me laugh. All right, so just by way of review, we have an animal class, okay, with a constructor, getters and setters for name and weight, and a speak method that we just left a pass in there because we want it to be overridden by the classes that inherit from animal. And here we have a cat class, constructor, which calls the superclass, or the one that it's inheriting from, and gives it that information, and then adds color. Getter and setter for color, and here we've overridden the speak method and make the cat say meow. In the same vein, just like that, we've created a dog class, okay? And I now have the dog constructor doing the same thing, getters and setters for color, and here I've overridden the speak so that the dog says woof. And then, in way of testing, I've created 3 objects. 1 is created with the cat class, 2 are created with the dog class, names, weights, and the color. Okay? So when I run this, you'll see off to the side, nothing happens because I didn't print anything out. Let me do that. Print. I will print, let's see, cat 1 dot get name, and then cat 1 dot get weight, and we might as well do everything. Cat 1 dot get color. Okay, that gets everything. I misspelled that, but I saw it, so I should be okay. I highlight this, paste, paste. And instead of cat 1, I want this to say dog 1. this to say dog1, and this to say dog1. I should have waited and pasted this after I made them all dogs. And then dog2, and dog2. So basically, I'm just getting a data dump of all the things we just loaded up. But let's run it and see. Okay, I got Felix, Fido, and Rex there printed out on the screen. Okay, so I've got two classes, cat, dog. They both inherit from animal. I'm creating objects. Then I'm spitting out, their different variables and stuff like that. I can even show you some polymorphism and have dog2 speak so that you can see he says woof. I can't even spell speak. So you can see that behavior right there. He says woof, and you got all of that. What if I wanted a way for me to keep track of how many objects I have with a certain class? Okay? Right now I have 3 animal objects, 1 cat object, and 2 dog objects. What if I wanted a way to keep track of that? Now, I guess you could set up a counter and you could do it in your main program, but is there a way I can do it with the different classes and the class setup? Well, it turns out there is. There's something called a class variable. We've been dealing with instance variables. Here, self.color, up in animal, name, self.name, self.weight. Those are instance variables. Those are for just the instance. Okay, cat 1, Felix, he has his own information. Dog 2, Rex, has his own information. Okay, those are instance variables. But I can also have class variables that can be accessed by any object that is created with that class. And they're really simple. I'm going to do mine in animal. Okay, so that way when I inherit from it, I'll also have the ability to use that class variable. And it's real simple. You do instance variables here in the constructor. You do class variables outside. I'm going to call mine A count or animal count. And you're going to see it's because we count the animals, okay? So I'm going to set it equal to 0 when it first starts, okay? So when I first instantiate an animal object, it creates a superclass. It creates an object for just the class. And in that object is where all of the class variables are held. So the first time this gets run, it says A count equals 0, and it sets the variable, and you don't have to worry about it anymore, okay? Now, when I create one of these objects, I want that variable to be incremented by 1. So where would that happen? The pregnant pause, so you can answer yourself. It happens in the constructor because I want to do everything I want to do when I first create a class in the constructor or create an object. Okay? So what I'm going to do here is I'm going to say A count plus equals 1. And I'm going to click that counter. Now I know from past experience that if I run this, it's going to explode. Watch. Whoa, that's a pretty good one. So it's blowing up because it sees that A count and it doesn't know what it is. I'm doing things in an area that's used to dealing with instance variables or stuff like that. If I want to use a class variable, I need to tell it the class. Now this isn't like a self situation. I know what the class is because I've already named it. It's animal. So if I say animal.aCount, increment that by 1, all of a sudden things run again. So what does that variable say? There's no way to know. You know why? Because we haven't done a getter or a setter for it. I'm not going to do a setter because we're setting it ourselves when we create different animals. But I will create a getter for it. So def get, we'll call it aCount self, and it returns just what it is, animal.aCount, and that's it. Okay, so now return, I don't need an S there. So now when I call get aCount, it'll return that variable and I can print it out. And how am I going to test that? You know how I'm going to test it. I'm going to say print, and I can use any of the object variables. I'll use dog2, and I'll say get aCount. And now when I run it, it tells me 3. Okay? If I want to, I could run it. Copy. after I create every object so we can see it being incremented. All right, get rid of this one. So now when we run the code, hello. All right, I can't use dog2 if it's not created yet. So I've got to come here and I've got to start using the proper variable names. Dog1, dog2. All right, look at that. 1, 2, 3 as they were created, and then we print their information. Okay? So now, interestingly enough, we have a way to keep track of how many objects we've created. But there's another point that's probably more important. We now have a place where these objects can talk to each other and actually pass messages and let people know things. If something goes on in a method in dog1, I can set a variable that's a class variable, and then I can have dog2 read it. Okay? So now, all of a sudden, my objects can talk to each other. In programming, we call that messaging. And it's a good thing for different objects in a system to be able to talk to each other. The example I always use is when you do game programming and you have a class that's an enemy, be it a spaceship you got to shoot down or a zombie or whatever. Whenever you create an enemy, you keep a track of how many of them you have. Okay? So that way you always know what the enemies are, and the enemies can all talk to each other. You can set class variables that say, oh, the person is here, the person is there, and then the enemies know where the object is and can go towards it. There's a whole bunch of different things you can do with passing messages. Now, using that example, what if I have a game where there's 20 zombies, okay? And all of a sudden, boom, boom, I kill a zombie, and it goes away. Well, then we have to delete that zombie, and we have to decrement that counter by 1. How would we do something like that? How do we get rid of an object? Well, it turns out there's a way to do it. The way you get rid of an object is you use DEL. You use the DEL keyword. As you could probably guess, it stands for delete. Okay? And then all you have to do is put the object you want to delete. Okay? So if I want to, I can delete Felix. I'm euthanizing Felix. Okay, so then after I do that, I will only have dog1 and dog2. Now, if I get rid of Felix, then I try to access cat1, I'll get a big error. And it'll tell me I can't do it anymore. Okay, but that doesn't really solve our problem, and I'll show you why. Watch when I run it. Okay, I deleted Felix, but the count is still 3 because things don't automatically happen like that. We have to make it happen. Now, when I delete cat1, a method gets run in the class called Dunder, D-E-L, Dunder. Okay? All it does is free up the memory in the object, though. It doesn't do anything special. We, kind of like we do with speak, have to override it if we want it to do something special. So what I'm going to do is I'm going to come here, and when you create an object, you have your constructor, which is underscore Dunder init Dunder. When you get rid of an object, you have something called a deconstructor. Okay? Your deconstructor, or what happens when you delete an object in Python, is Dunder del Dunder. All right? And then I'm going to say self, and what I'm going to do is I'm going to say print an animal has been destroyed, and then I'm even going to go so far as to tell you who it is, and I'll say self.name, so that when I run destroy on something, I'll print its name out so you know what's been destroyed. And then what's the second thing I want to do? Oh, okay, I was going to say, why isn't that going back there? What's the second thing I want to do? I want to decrement the counter. So I want to tell it what the class is, I want to tell it what the variable is, and I want to decrement by 1. Okay, so now when I destroy the animal, it'll tell me the animal I destroyed, in this case Felix, and it'll decrement that counter. So when we come over here, we'll see Felix has been destroyed, and we should see it too. Okay? Let's go see if that works. All right, an animal has been destroyed, Felix, and the counter is decremented by 1. So it now says 2. All right? Not going to go through a whole crazy trace, but when I ran del cat1, what happened? Cat1 is an object created with the cat class. I go to the cat class and I say, hey, I'm destroying this object. Is there a method that's dunder del dunder? Nope, nope, nope. No, there isn't. But I know I inherit, so I go to the animal class. Does the animal class have something that says underscore del dunder? You go all the way to the end, and the answer is yes. So this is the method I'm going to run when I destroy my object. I print an animal has been destroyed, and the name, self.name, was defined up here when we created it. So an animal has been destroyed, Felix, okay? And then I decrement the counter. So the counter that was 3, set right there, now becomes 2. And then I return to the call. So when I do that, I come down here, print dog2. I'm accessing it through the dog2. I can access those class variables through any of these variables. I'll go show you a dirty little secret in a second. Get a count. So I go to get a count. First it looks for it in dog, doesn't find it, but then it looks for it in animal, and it does find it. Get a count, it returns animal.acount, which is now 2, and it prints 2. Okay. Here's your dirty little secret. We don't get into it because we don't talk about encapsulation much. But I don't need to have an object if I want. I can just print it out raw like that. I can tell you what the class is, and I don't want to do that. And I think that'll work. Yes. Okay? Because we have public access, because any part of your program can access variables in the classes. I don't even need an object. I can just print the damn thing raw. Okay? As I think I've told you before, I skip encapsulation. It deals with public, private, protected. Those of you who know a little bit about Java or C++ know what I'm talking about. I got to make choices. So I think it's more important to learn about inheritance. Inheritance is the important thing. A little bit about polymorphism, and then these things, then encapsulation will drive you nuts. And at the end of the day, it's not that important. Because a lot of people, when you get out in the real world, you're just going to go along with whatever that particular coding team is doing with their particular product, and it's not going to affect you in any way. So if you're confused by that, just forget about it. If not, at least you know. All right? I'll actually leave it like this so that you can get that. All right? So we've got a pretty sophisticated setup here. We now have a dog class, a cat class. They both inherit from animal. Animal now has a class variable that we use to keep count of how many objects we have. So in our constructor, we increase it, and now we have a deconstructor. So now we can get rid of objects, and we can decrease that counter when we get rid of objects. Okay? So as the programmer, you got to remember, you can't access something if it's been destroyed, but right now we're pretty good. We had a cat and 2 dogs. We got rid of the cat, so now we only have 2 dogs, right? Okay. Second to last thing we're going to do. One of the things we're going to do is this, and I think I alluded to it before. Print dog2. Now, all along, you've been printing variables, right? You print an integer, you print a float, you print a string. You can even print lists, okay? If you put them in the print, it basically takes the data, and it throws it out. But what gets printed when you print an object? Okay, there, let's try it. And we've seen it before when we talked about self. We see there's a dog object at, and it gives you a memory address. And if you think about it, that's all really Python knows about that. Okay, Python isn't going to be sophisticated enough to read your class and go and dump out all your data items or anything like that. So if I ask for dog2, it comes back and it says Rex 55 red. It's not going to do something like that. We have to give it that functionality. Okay, the secret behind the scenes is that when you run print on an object, there's a method that gets run, okay? So we are going to override that method and make the print statement do what we want it to do. That method, and I'm going to do it right here above the del, is dunder string dunder, dunder str dunder, okay? And I think it just takes self, and it returns a string. So what we want to do is create a string. So I'm going to say a string equivalent to, and then I'm going to call it data dump, comma, and then I'll say self.name, self dot weight. Now remember, I'm doing this in animal. Animal doesn't know what color is, okay? So I'm not going to dump that. If I wanted to, I could do dunder string dunder in cat or dog if I wanted to do that. For these purposes, I'm just going to do it here in the superclass. I'm going to say self.name and self.weight. And that's it. Oh, I don't want to do that. What should I be doing? Oh, I should be concatenating is what I should be doing. So I'm creating one string, and then I need to return it. So I'll return a string. I won't return it. I will return it. Okay? So now when I do print dog2, it'll say dog2 is created with the dog object. Let me come up here. Is there a dunder string dunder? No, but I inherit from animal. So let's go up to animal, and I go down here. Yes, there is a dunder string dunder. So I'm going to create a string. I'm going to call it data dump. You'll get the name and the weight. So you'll get Rex and 55. And they'll be right next to each other. I'm not going to separate it. And then I return that string, and that string is what will be printed out when we print dog2. If the programming gods are with us. Let's do a run. Oh, dun 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 dun. Trace back most recent call. Oh, interesting. Self.weight und is an integer. Yeah, so make it another integer, dopey. That's what you want to do. Cast it to a string. Okay, so if we do that, name is a string. That is now a string because we made it a string. And look at that, data dump Rex 55. So what we did was we overrode the string method. Now you might be saying to yourself, Lars, override del, override string? No, you didn't. That's the base class. That's where you define all the classes. What you'll come to know when you get more into Python is that when you create an object, when you create a class, it's really inheriting from a big superclass, which has all of those things written already. Dunder init dunder, dunder del dunder, dunder string dunder, plus a whole bunch of dunders I'm not mentioning because I don't want to confuse the hell out of you. You'll get into it as you read books and you get more into Python, especially object-oriented Python. Okay? I'm overriding the big Papa class. Okay? When I do my constructor, I want it to be my constructor. When I do my del, it's my del. When I do my string, it's my string. So basically, when I create my class, I'm telling people what I want to come out when people print it, okay? And back in the old days when object orientation first came around, late 80s, 90s, stuff like that, people used to say, well, if you print an object, what are you printing? Do you print just the data? Do you print the data and the methods you can run on it? Do you do something else? What do? Do you just give the name of it? This class whatever, object this? You know, and there's no good answer to that. So what I always did was I always wanted what we used to call a state dump. I wanted to know what all my variables were in that particular object. And I kind of know tangentially what I can run on that data, but I want to know what the data is. We call that a state dump. What's the state of everything at that given moment? So that's usually what people do, is they do data dumps. So I just dumped the two instance variables that animal knows about, okay? All right, so we're in good shape. We have, really quick, whipped up a dog class. So now we have two classes inheriting from animal. We've dealt with class variables. So now we can have our objects talk to each other and message each other and access the same variables. We now know about deconstructors, which are the opposite of constructors, and how we can run our own special thing when we run the del command on objects to get rid of them. And now we understand what print does. If we override the dunder string dunder and send back a string, that string will be printed out when we run that code. You can see here, data dump, Rex 55, okay? So we're in pretty good shape. There is one last thing I am going to do, okay? I'm going to save this, and I am going to rename it. I'm going to say File, Save As, and I'm going to call it analyb.py. And what am I going to do with analyb? I'm going to take all of this code right here. I'm going to cut it so that I save it, and then I am going to delete it. Okay? So now I have my dog class, I have my cat class, and I have my animal class. Look at that, ahead of time I already called it the animal library. and I have analib. Let's get a new file. So I now have a new file. All right. You notice that I got it from the code, so it's going to put me in the right directory. I say save. It is in the right directory. I'm going to call this animain. And in animain, I'll call this the main animal code. I'll come down here, paste, boom. Okay, and there's all my driver program. Not really testing it because I'm using something. Now, if I run this, is it going to work? No, it's going to blow up all over God's creation because I need to tell it where to go. Now, so this code works, so I'm going to do what I always tell you not to do, and I'm going to say from analib import animal cat dog. Okay, save that. What does that look like? Importing functions, right? Importing classes is the same exact thing. I can now import classes and then use them in my regular code. So I can have what's called a class library with all of my classes in it. You see all that stuff in the library? And then I come out here and I import it. And then I can use it all. So now when I run this, it's the same thing as we were running it before. But I've compartmentalized like we used to do with our functions. So now the final thing we were going to talk about in this video, we have modularity. Okay? So we're in really good shape now. All right? So if you look at the code, we have we import our classes, and then we have a whole bunch of commands here that are using the information we get. We're creating objects. We're running methods on those objects and printing things out. We deleted an object. We're learning about what happens when you print things. Here, you're just going and grabbing your raw class variable and printing it out. So we did some good stuff. All right? This is your class library. So when you create a system and things like that, you just take all your classes and you put it in a library, and then in a separate program, you run it all. Okay? What you would also provide people is what's called an API. Okay? So that people know what your classes are about and how to use them and how to load your library. When you get libraries from third-party sources or from whatever, this is what it's going to look like. You're just going to get a third-party library for someone. You're going to say, oh, there's that class, there's all this stuff. Okay? All right. Then that's it. I'm going to take this code, animain and analib, and I'm going to throw it on Sakai. So I want you to take it and play around with it. Start doing stuff. Make changes. Make sure you understand it. Add another class variable. Tinker around. Delete some dogs. Kill some dogs. All right? See what happens. Play around with this stuff because that's how you learn. You don't just watch me doing it. You play around with stuff. All right? So that's the last video for Big Bad Unit 5. I'm going to be giving you the assignment probably in a couple nights, maybe on Thursday. And you're going to see then, you're going to have to deal with, I don't know, should I let the cat out of the bag? You probably already know from all the people who have taken it in the past. But basically what you're going to have to do is you're going to have to come up with a class that mimics a deck of cards. And then you're going to have to play a game with that deck of cards. All right? You'll get the assignment in a couple of nights. I have to go home and do laundry and pack and get ready because it's 6 o'clock tomorrow morning. I'm driving to Boston because I'm going to the PAX Festival Conference, whatever you call it. PAX is Penny Arcade Exchange. And that's where all the video game stuff is, and that's where board games, a whole bunch of stuff. So all weekend is going to be fun. Hopefully I can get my butt into Fenway on Saturday to see the Red Sox play the Rays. So I get a little baseball, see Boston, take care of the PAX conference, maybe go up and talk to some people I know at Harvard, see what's going on. All right? So, announcements. Really only 2. Well, 3. 1, Kit and Qasim are grading up Unit 4. Hopefully, maybe sometime over the weekend when I'm in Boston, or right when I get home, you'll get back your grades. You'll definitely get them back before the end of Unit 5. Same thing for the midterm papers. I am now in the middle of grading them. They're very interesting. Some of them are good. You'll get back grades that I promise, Unit 4 grades and paper grades, all before the end of Unit 5. Okay? Your proposal for your final project is due Friday in 3 days on April 6th, okay? Don't sleep on it. If it shows up, I want you to take it and put it in the Dropbox of somebody in the group, and then that person sends me email and says, hi, I'm from group 3. Go look in my Dropbox for the proposal. And then I'm going to load up all the proposals, and because they're the proposals, when I get them, I will look at them as soon as possible, because then I can say, this is good, or you know what, you need to do this, you need to do that, redo it, which doesn't happen often, but sometimes it does, so be ready. And then you can spend the rest of the time doing the design document, okay? And then when you hand in the design document, the proposal is the only thing I have to approve. Once you send in the design document, then you just keep going. And then you start worrying about the code and the demonstration and all that kinds of stuff, all right? I'll be in touch tomorrow night. Once I get settled in the hotel, I'll look in forums, and I will be doing announcements. And so you have no worries then. And Thursday night from Boston, I plan to upload the assignment. So you'll have the assignment with a lot of time to work on it, which I like to give people in Unit 5. Okay, so everybody's doing good. Everything is fine so far. Keep your eye on the prize. Engage with the slides. Watch all of these videos. If you're listening to what I'm saying right now, you're good, because you're at the end of the last video. So you should be in good shape. But rewatch the videos. Make sure you understand what's going on. And then Thursday, I'll get you the assignment. All right? All right. Then I'm going to get out of here. You be good. And we'll talk to you very soon. All right. Bye.